All right, guys, here is the 5-1 to 5-4 test review. I don't know how to make them. I'm just going to put this over here, and I'll bring this up so you can see. First thing we're going to do is talk about our identities and stuff. If you guys have seen, I don't know if anybody was paying attention or not, but I have already posted the worked out review. It's completely worked out, step by step by step by step by step, and it's on Canvas for you guys to look at. So make sure that you do that, please. So the first thing we're going to do is just look at our Pythagorean identities and stuff like that. I'm going to leave secant squared for the first part because remember, we want to make things smaller. So I'm just going to leave secant squared, or if you wanted to rewrite it to 1 over cosine squared, feel free to do that. You can do that. Now, when I look at 1 minus sine squared, guys, we go back to that Pythagorean identity. Reagan, we go back to that Pythagorean identity of sine squared x plus cosine squared x equals 1. If I move this over here, I could say that 1 minus sine squared x is the same as cosine squared x. So I'm going to replace that with cosine squared x, and this is over 1. And if you guys notice, cosines and cosines cross out, give me 1. And that's what I was trying to get. So 1 equals 1. There's your verification. But look at the second one. Remember, please, I told you guys yesterday, please change the tangent to tangent squared. But if you look at your Pythagorean identities, and we know that cosecant squared minus 1 is the same as cotangent squared x over 1. And then I have times tangent squared x over 1. You can rewrite this in terms of sine and cosine. So I have sine squared x over cosine squared x times cotangent is cosine squared x over sine squared x. And if you notice, your cosines will cancel out. Then your sines will cancel out. And you're left with 1 on this side equals 1 on this side, which is what we were looking for. Here again, we have identities. You guys notice I have this secant squared x minus 1. That makes me want to look right at my identity sheet. I will give you your identities on your test, so don't worry about that, but it'll make you look right at your identities. If you look at your identities, there is a identity that says 1 plus tangent squared x equals secant squared x. So look, if I move this 1 over here, would you guys agree that tangent squared x is the same as secant squared x minus 1? So I'm going to replace this with tangent squared x. And I can rewrite cosecant as 1 over sine squared x. And then I can look at this and I can say, okay, 1 over sine squared x. Tangent, I can rewrite that as what? Sine squared over cosine squared. Good. So my sines cancel out. I have 1 over cosine squared x, which to simplify and rewrite it as one single term, I can write that 1 over cosine is secant squared x, which is what we started with, what we're trying to get to. So secant squared x equals secant squared x. Okay, guys, when we get down here to solving, all right, we're going to be using our unit circle. You can use the unit circle on your test, all right? I will put all of this together. It's probably easiest if you print it out so you have it in front of you, because you're going to be in lockdown, so it's going to be hard to go back and forth, back and forth, back and forth. But if I were you, I'd get all this stuff printed out, have it in front of you so you don't have to worry about trying to look for it during the test. If we're solving, okay, remember, we're solving. We want to get this trig function all by itself, tangent squared of x. So the first thing I'm going to do is I'm going to add 3 to both sides. And when I do that, I get that tangent squared x equals 3. In order to get tangent by itself, I'm going to undo the squared. So if I take the square to one side, I take it to the other side. So I have tangent x equals, remember we put the house on, so it's plus or minus root 3. So I'm looking on the unit circle where my y over x value is positive or negative root 3. Remember, I told you the easiest thing to do is next to your ordered pairs. This ordered pair right here gives me square root of 3 for my tangent. This one right here gives me square root of 3 over 3. It's good to memorize that. So I'm going to look all in the unit circle where my ordered pair is 1/2, comma, root 3 over 2. So that's going to be at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So my answers would be x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And we would circle or box or whatever all of those answers. Remember, all of these equations that we're solving are all over the interval of 0 to 2 pi unless we're talking about multiple angles, which in this case we're not. All right, moving over here to number 2. All right, I see I have cosine. I have the same function on both sides. So let's get all of our functions together. So I'm going to add 2 cosine theta to both sides. So that gives me 4 cosine thetas. Cosine theta plus 4 equals 0. Trying to get cosine theta by itself, so subtract 4 from both sides. I have 4 cosine theta equals negative 4. Divide both sides by 4. And I end up with cosine theta equals negative 1. So that means I'm looking for x values on the unit circle that are negative 1. And when I do that, the only one is right here at pi. So my answer here would be x equals pi. All right, moving along here, I have sines. Same function, just on opposite sides of the equal sign. So let's get them all together. Whoops, I have to highlight that. So I have sine theta, sine theta. So just do what we did just a second ago. I'm going to add 2 sine theta to both sides, plus 2 sine of theta. So I have 4 sine of theta plus 2 equals 0. Subtract 2 from both sides, and I get 4 sine of theta equals negative 2. Divide by 4 on both sides, and I get sine of theta equals negative 1/2. Remember, sine is our y value. So I'm going to go to my unit circle, and I'm going to find all the y values that are 1/2. So when I go up here, I'm sorry, negative 1/2. So that's going to be at 7 pi over 6 and at 11 pi over 6. So I have x equals 7 pi over 6 and 11 pi over 6.
Yes.
Box that out. All right, moving over here, I see tangent squared. Tangent squared x, I want to get that all by itself, so I'm going to subtract 3 from both sides. So I have tangent squared of x equals 4 minus 3 is 1. Take the square root, so I'm looking where the tangent of x is, square root of 1 is 1, so it's plus or minus 1. So I'm looking on the unit circle where my y over x values give me positive or negative 1. Well, that's going to be it, where everything is root 2 over 2, root 2 over 2. So it's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, now we come to number 8. Number 8 looks a little different. And the reason that number 8 looks a little different is because we have something called multiple angles here. You know that it's multiple angles because there is a number right here in front of your x. So I have to think, okay, since this is cosine, I'm going to have to add 2k pi to my answer because it's a multiple angle problem. Now we solve it like normal. I look at this, cosine 2x is all by itself, so that means I'm looking for x values on my unit circle that the x values are negative 1/2. So I go to my unit circle, x values negative 1/2 is going to be 2 pi over 3 and at 4 pi over 3. So my unit circle, I'm going to have 2x equals 2 pi over 3 plus 2k pi. And again, that 2k pi because we have multiple angles. And then I have 2x equals 4 pi over 3 plus 2k pi, meaning I can go around the unit circle 10 times, 1 time, 4 times, and up at that same spot. So now we go about solving like we normally would. We're going to divide everything by 2. So this becomes x equals 2 pi divided by 2 pi over 3 divided by 2 is 2 pi over 3 times 1 over 2 gives me 2 pi over 6, which is going to reduce to pi over 3 plus the 2's cancel out, k pi. Divide everything here by 2 and I get x equals 4 pi over 3 times 1 over 2 gives me 4 pi over 6, which is going to reduce to 2 pi over 3 plus k pi. So there's my two answers. And remember, we have our k pi or plus 2k pi at the end because it's a multiple angles problem. All right, same thing here. I look here, and this is a multiple angles problem because when I look at my trig function, there is a number in front of the theta. Stuck to it. So let's get our trig function by itself. We're going to add 1 to both sides. So I have 2 times the sine of 3 theta equals 1. Divide by 2. So sine of 3 times theta equals 1/2. Okay, that's our y values. Where on the unit circle are our y values 1/2? So I go up here. 1/2, positive 1/2 for y would be pi over 6 and 5 pi over 6. So I'm going to say 3 theta equals pi over 6 plus 2k pi, since this is a sine function. And then 3 theta equals 5 pi over 6 plus 2k pi. So now we go about solving like we normally would. We're going to divide everything by 3. So I get theta equals, if I have pi over 6 divided by 3, it's pi over 6 times 1 over 3 gives me pi over 18. So it's pi over 18 plus 2k pi over 3. Here I'm going to divide everything by 3. So I have theta equals, if I have 5 pi over 6 times 1 over 3 gives me 5 pi over 18 plus, again, that 2k pi divided by 3. And again, guys, sine and cosine, you add 2k pi. If it's tangent, you add just k pi. Looking here at number 10, guys, again, this is a multiple angles problem. I know it's multiple angles because there is a 3 in front of my x.
Zoe.
So I look and I say, okay, sine is y values. So where are the y values on the unit circle? Positive root 3 over 2. So positive root 3 over 2 would be pi over 3 and 2 pi over 3. So I'm going to say 3x equals pi over 3. And since this is a sine function, it's plus 2k pi. And then I have 3x equals 2 pi over 3 plus 2k pi. Again, because it's a multiple angles and it's sine, it's plus 2k pi. So as we go to solve, we're going to divide everything by 3. So I have x equals pi over 3 times 1/3, keep change flip, is pi over 9 plus 2k pi over 3. Divide everything by 3, and I get x equals, you have 2 pi over 3 times 1/3, keep change flip, gives you 2 pi over 9 plus 2k pi over 3. All right, guys, moving along to number 11. You see here, you have the same trig function, cosine. First term is squared, second time isn't. This is where we think quadratic. And since it's the exact same trig function, you can rewrite this as just 2. Replace your trig with x's. So 2x squared minus x minus 1 equals 0. If I was going to factor this, a times c. What are the factors of negative 2 that multiply to give me a negative 2 but add to give me a negative 1? So be x minus 2, x plus 1. Replace now, or I'm sorry, our a term is not 1, so I'm going to divide both by 2. So I'm left with x minus 1. This doesn't divide pretty, so then 2x plus 1 equals 0. We can now replace our trig function, our x with the trig function, so remember it was cosine. So I'm looking for cosine x minus 1 equals 0. 2 cosine x plus 1 equals 0. So if we solve this, we're going to add 1 to both sides. So I'm looking on the unit circle where the cosine of x is 1. That's my x value. And then over here, I'm going to subtract 1. So 2 cosine of x equals negative 1. Divide by 2. And I'm looking on the unit circle where the cosine of x is negative 1/2, which is, again, our x value. So we're going to have 3 answers here. X equals, first I'm going to look for is where cosine x values are 1. So where my x value is positive 1, it's at 0 or 2 pi, however you want to say it. I'm going to write 0/2 pi. I would take either answer. And then where x values are negative 1/2. So I look on my unit circle. X being negative 1/2 would be 2 pi over 3 and 4 pi over 3. So you can write 2 pi over 3, comma 4 pi over 3, and box out your answer. Okay, look at number 12. I have a trig function squared, and I have 1 to the first power. They're both the same, so I'm just going to rewrite this as a normal factoring problem. 2x squared plus x minus 1 equals 0. A times c is negative 2. Factors of negative 2. That multiply to give you negative 2, but add to give you a positive 1, be x plus 2, x minus 1. My a term is not 1, so I divide both pieces by that. So I have x plus 1. 2 becomes my coefficient, so 2x minus 1 equals 0. And now I'm going to replace my x with the trig function we start off with. So it's sine of x plus 1 equals 0. 2 sine x minus 1 equals 0. So solve, minus 1 from both sides. I'm looking for sine values of negative 1, that would be y. Here I'm going to add 1 to both sides. So 2 sine of x equals 1, divide by 2. And I'm looking for sine values to be positive 1/2. That's again y. So we're looking on the unit circle to where I have y values of negative 1. So let's look there first. My y value of negative 1 would be 3 pi over 2. 3 pi over 2. And where my y values would be positive 1/2. So pi over 6 and 5 pi over 6. So pi over 6 and 5 pi over 6. And box your answer. Okay guys, coming over here and looking at number 13. This is the same kind of problem. It is a quadratic, but if you notice, the two functions are not the same. I have a cosine squared and I have a sine. I told you in class, when you have a quadratic and the functions are different, you want to convert to whatever the middle trig function is. We're going to go back to our trusty Pythagorean identity, all right? That Pythagorean identity is sine squared x plus cosine squared x equals 1. If I want to change, I want it to say cosine equals. So if I move this over here, I can replace cosine squared x with 1 minus sine squared x. And then my trig functions would all be the same. So I'm going to replace this with 1 minus sine squared. So it's 2 times 1 minus sine squared x, right? Cosine squared is the same as 1 minus sine squared. So plus 3 sine x minus 3 equals 0. Now we just distribute, so I have 2 minus 2 sine squared x plus 3 sine of x minus 3 equals 0. Combine like terms, I have a 2 and a negative 3, so that gives me negative 2 sine squared x plus 3 sine of x minus 1 equals 0. All right, we're leading with a negative here. We don't like that, so I'm just going to divide out a negative 1 from everything. So that'll leave me with positive 2 sine squared x minus 3 sine of x plus 1 equals 0. Now I have a quadratic that has the same trig function. One is squared, one is to the first power. So I can rewrite this and I can think of it algebraically. So 2x squared minus 3x plus 1 equals 0. What are the factors of 2? Multiply to give me a positive 2, but add to give me a negative 3. That'd be x minus 2, x minus 1. My a term is not 1, so I'm going to divide both things by 2. So I have x minus 1. This becomes my coefficient. 2x minus 1 equals 0. And now we replace with our trig function and use our unit circle. So this first parenthesis would be sine x minus 1 equals 0. Second parenthesis would be 2 sine x minus 1 equals 0. So we solve this equation. We're going to add 1 to both sides. Sine of x equals 1. Over here, I'm going to add 1 to both sides. I have 2 Sine x equals 1, divide by 2, and I get the sine of x equals 1/2. So again, we're going to look for y values on the unit circle that are 1 and y values on the unit circle that are 1/2. So I have x equals y values on the unit circle that are 1, going to be all the way up here, would be pi over 2. So x equals pi over 2. And then I need where y values are 1/2. And that's going to be at pi over 6 and at 5 pi over 6. So we have pi over 6 and 5 pi over 6. And box your answer. All right, moving along to this last one. Again, we have a quadratic. I see a function, I have a trig function squared, and I have one that is to the first power, but they're different. So like I said before, guys, let's look at that middle function, and let's convert everything to that middle function. So we're going to use our Pythagorean identity. I can replace sine squared with 1 minus cosine, so this would be -2, 1 minus cosine squared theta, plus 3 cosine of theta, plus 3 equals 0. We're going to distribute my -2, so -2 times 1 is -2. -2 times negative cosine is plus 2 cosine squared theta, plus 3 cosine theta, plus 3 equals 0. So I can now combine like terms. So I have 2 cosine squared theta, plus 3 cosine theta, plus 1 equals 0. So now that I have my trig functions the same and it's a quadratic, I'm going to think algebraically. So 2x squared plus 3x plus 1 equals 0. Multiply a times c. And I say, okay, what are the factors of 2 that multiply to give me a positive 2, but add to give me a positive 3? And that would be positive 2, positive 3. So I can rewrite this as x plus 2, x plus 1. I'm sorry. 2 times 1 is 2. 2 plus 1 is 3. So continue our factoring. Since my a term is not 1, I'm going to divide both sides by 2, both factors. So I'm left with x plus 1, and this becomes 2x plus 1 equals 0. Now I'm going to replace my x's with my trig function, so we changed everything to cosines. So this is going to be cosine x plus 1 equals 0, 2 cosine x plus 1 equals 0. And we're going to come right up here and solve. So let me rewrite this as cosine x plus 1 equals 0. 2 cosine x plus 1 equals 0. Subtract 1 from both sides. Cosine of x equals -1. Minus 1 from both sides. I have 2 cosine x equals -1. I'm going to divide both sides by 2. And I get cosine x equals -1/2. So here, guys, we are looking to where my cosine values, which are my x values, equal -1. And where my x values are -1/2. So let's go to our unit circle and look for that. So I need x is -1. Over here's my unit circle. So x being -1 would be pi. So I have pi, comma, and then I need where x would be -1/2. So my -1/2 would be 4 pi over 3. And 2 pi over 3. So we will write that as 2 pi over 3 and 4 pi over 3. And you can box your answer. All right, these next problems are having you guys use your sum and difference formulas, your identities, okay? If I'm talking about finding the tangent, now tangent is the hardest one that we're going to do, that's why I put 2 of these on here. But if I'm talking about tangent, and I'm trying to find the tangent of a number, okay? Of a what am I trying to say? An angle, all right? That is not on the unit circle. You have to find 2 angles that are on the unit circle that either add up to or subtract to give you the angle that's given. So I'm going to just think of 150 is on the unit circle and so is 45. There's different combinations, so you guys can do whatever you want, but I'm going to rewrite this as the tangent of 150 degrees plus 45 degrees, all right? That's what I'm going to focus on because 150 plus 45 gives me 195. So I'm going to use the tangent u plus v formula, which is right here, this one. So I'm going to say that 150 is my u and 45 is my v. So I'm going to rewrite this as the tangent of u, which is 150, plus the tangent of v, which is 45, divided by 1 minus tangent 150 times tangent 45. Now the way that you would work this out, guys, the easiest thing to do is say, okay, what is the ordered pair at 150 degrees? What is the ordered pair at 45 degrees? Well, I know off the top of my head that 45 is root 2 over 2, comma root 2 over 2. And the tangent of 45, when I put root 2 over 2 divided by root 2 over 2, is just 1. The ordered pair at 150, we got to go to our unit circle. And the ordered pair here is negative root 3 over 2, 1/2. So I have negative root 3 over 2, comma, 1/2. So if I was going to tell you guys what the tangent of 150 is, so I can just plug it into my formula quickly, it would be 1/2 divided by negative root 3 over 2. So that's going to be 1/2 times negative 2 over root 3. So cross this out, I get negative 1 over root 3. This is going to be negative root 3 over 3. So the tangent of 150 is negative root 3 over 3. Now we're going to use those two values right here to plug into this formula. So, and then we simplify. So I'm going to rewrite this as tangent of 150. Well, the tangent of 150 is negative root 3 over 3. Plus the tangent of 45 is 1. So I'm going to write that as 3 over 3, it's the same as 1, but so it has a common denominator. Divided by 1 minus, well, the tangent of 150 is root 3 over 3 negative, times tangent of 45, which is 1. So here, guys, I'm going to replace this 1 with 3 over 3. So if I simplify this, in the numerator, I have negative root 3 plus 3 over 3. And then in the bottom here, I have 3, 2 negatives gives me plus root 3 over 3. Right? This is root 3 over 3. So now in this case, I'm going to change, flip. So when I do that, I have negative root 3 plus 3 over 3 times 3 over 3 plus root 3. This will cancel out, so I'm left with negative root 3 plus 3 over. This should be 3 plus root 3. Now, you can go ahead and rationalize beyond that point. You guys could multiply by the complex conjugate. At this point, we're not going to ask you to. You're good to just leave it just like that. It gets hairy, I understand that, but the best thing to do is to find the tangents and then be able to kind of look at them that way and without trying to do y over x over y, that sort of thing. What I'm saying. Okay, so now we're going to go to 16, is this? Okay, and we're talking about the angle 105. Well, 105 is not on the unit circle, so we're going to find two angles that either add or subtract to give me 105. Again, it could be a variety of combinations. You don't have to always pick the one that I do, but I'm going to use 60 degrees plus 45 degrees. So I'm going to say tangent of 60 degrees plus 45 degrees. That's what I'm going to find here. So again, I'm going to say my ordered pair, this is my u, this is my v. My ordered pair at 60 is 1/2 comma root 3 over 2. My ordered pair for v, which is 45, is root 2 over 2, root 2 over 2. So I'm going to use the tangent angle plus angle formula. So I'm going to write it out over here, and I'm going to say tangent of 60 plus 45. And that's going to be tangent of u. So the tangent of u would be root 3 over 2 divided by 1/2. That's going to give me, tangent's going to be root 3. And here, again, my tangent for 45 is just 1 because root 2 over 2 divided by root 2 over 2. So I have tangent of 60 plus 45. So it's the tangent of u, which is root 3, plus the tangent of v, which is 1, over 1 minus the tangent of u, which is root 3, times the tangent of v, which is 1. And then we're just going to simplify here. So I have root 3 plus 1 over 1 minus root 3. Again, you could leave it at this point if you wanted to. I'll show you what I mean when it looks like it's rationalized. We would obviously just get rid of we would multiply by the conjugate. So 1 plus root 3, 1 plus square root of 3. So when I do that, I'm going to come down here. And when I FOIL, I have root 3 times root 3 times root 3 is just plus 3. And then 1 times 1 is plus 1. And then 1 times root 3 is root 3 over 1 times 1 is 1. Then I'm going to have a minus and a plus root 3, which will cancel out. Then I have minus root 3 times root 3 is just 3. So I can combine like terms here and here. So I have 1 plus 3 is 4 plus 2 root 3s over 3 minus 1 is negative 2. And then we can simplify that a little more. And 4 divided by negative 2 is negative 2. And then 2 divided by negative 2 is 1, so minus root 3. This would be our rationalized answer. But I would take either one of these. I would take here, or I would take here. All right, then when we come here, when we have sines in radian degrees, all right, sine and cosine is obviously much easier for us to do. First thing I would do is change my radians into degrees. So I would I'd convert pi over 3. And then I'd have 180 over pi, so that would give me 60 degrees. So I really have sine of 60 minus pi over 4. If I convert that, this becomes 45. So I have the formula that I need. I can look at it right here. I have Okay, moving on to 21. You look for the formula that says sine, cosine, minus cosine, sine. If you look over here at your identities, that happens to be sine of u minus v. So I'm going to rewrite this as the sine of u, which is 315, minus v, which is 15 degrees. So then I could rewrite this as the sine of 300 degrees. Then I go to my unit circle and I look what 300 degrees, what the ordered pair is, and it's 1/2 comma negative root 3 over 2. And I remind myself that sine is y values. So to rewrite this, guys, as one trig function and give the exact value, you would write sine of 300 degrees equals negative root 3 over 2. And that would be your answer. So that's how you simplify. You just pick the identity that matches what the problem looks like. All right, these last ones, guys, are really quite simple if you just pay attention to what you're doing. All right, they're giving you two different triangles. They're telling me this alpha and information about it, and they're telling me beta and information about it. And then they're telling me what they essentially want me to find in the end. So let's look at what's given. Let's kind of like dissect what they gave us, and then we can put it all together. So they're telling me that the sine in this alpha triangle is 3 over 5. So remember, sine is y over r. So in our triangle alpha, we have x, we have y, and we have r. All right, so I know the y value is 3. I know the r value is 5. Now I have to find x. So x squared plus y squared equals r squared. X squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. X squared equals 16. X equals 4. Okay, so I know I have x is 4, y is 3, r is 5. The second thing they tell me is that this angle, this triangle that we're talking about, lies in quadrant 1. So since, okay, one second. Since the angle lies in quadrant 1, I know that the x value and the y value are both positive. So this is the information that I need and that I know about triangle alpha. I know that the sine of alpha, I'm going to just write it out already, is y over r. It's 3/5. I know that the cosine of alpha is x over r, so it's going to be 4 over 5. And I know that the tangent of alpha is going to be y over x, which is 3 over 4. Okay, that's what we need to know. This is what we need to know about our triangle alpha. Now I'm going to come over here. I'm going to look at beta. All right, so now we're going to look at what they gave us here for beta. They told me sine of beta is negative 12 over 13. Okay, remember, sine is y over r. So I know that in triangle beta, I have an x, I have a y, and I have an r. I know that that negative goes with the 12 because r is always positive. So I know that y is negative 12 and r is 13. So now let's find x. X squared plus negative 12 squared equals 13 squared. So x squared plus 144 equals 169. X squared equals 25, so x equals 5. Now, the second thing that they told us is that beta lies in quadrant 3. Guys, if beta lies in quadrant 3, that means both my x value and my y value are negative. So that negative 5 is important that we write that in. So this is what we need here. So I can now write out sine of beta is negative 12 over 13. My cosine of beta is negative 5 over 13. And tangent of beta is negative 12 over negative 5. Y over x would be 12 over 5. So everything we need to answer the question of cosine alpha plus beta is right here. So now I'm just going to say, okay, I need the cosine of alpha plus beta. Well, if we look at our trig identities for sum and difference, let's pull it in real quick. I see that when I have cosine, I'm adding to the two angles. It's cosine, cosine minus sine, sine. So I'm going to say cosine of theta times the cosine of beta minus sine alpha, sine beta. So now we fill in from what we have above and we simplify. Cosine of alpha is 4 over 5 times the cosine of beta is negative 5 over 13 minus sine of alpha is 3 over 5. Sine of beta is negative 12 over 13. So when I simplify, 4 times negative 5 is negative 20 over 65. Minus, I have 3 times negative 12, that's negative 36 over 65. When I have two negatives, that gives me a positive. So negative 20 plus 36 is 16 over 65. And there's our answer. You always look to see if you can simplify that fraction, and if you can't, you're good to go. All right, let's look at the next one. Let's see what they give us. All right, they tell me that the sine of theta is negative 4/5. All right, sine is y over r. So for theta, x equals y equals r equals, all right? Y is negative 4. R is always positive, so that's going to be 5. So now we have to find x. So x squared plus negative 4 squared equals 5 squared. X squared plus 16 equals 25. X squared equals 9, so x equals 3. Now what they told us that's also very important is that this angle theta lies in quadrant 3. If it's in quadrant 3, both the x and the y are negative. So this is negative 3 and negative 4. So when I think about triangle theta, I know that the sine of theta, y over r, is negative 4/5. I know that the cosine of theta is going to be negative 3/5. And I know that the tangent of theta, y over x, is going to be 4 over 3. Important information for us. Now the second thing I'm going to do is look at the second thing, and they told me sine of x. So sine of triangle x is 12 over 13. So they said that's y over r. So triangle x, I have x, y, and r. So I know my y value is 12. My r value is 13, so I have to find what x is. So x squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. X squared equals 25, so x equals 5. So what did they tell me? Y is in quadrant 2. So if I'm in quadrant 2, that means my x value is negative, my y value is positive. So this is negative 5. So here's my information about triangle x. I know that the sine of x, y over r, is 12 over 13. I know that the cosine of x is negative 5 over 13. And I know that the tangent of x, y over x, is going to be 12 over negative 5. Again, important information for us, because what are they asking us to find? Sine of theta minus x. So I need sine of theta minus x. So what is the formula for sine when we're subtracting? It's sine cosine minus cosine sine. So I'm going to say sine of theta times the cosine of x minus cosine theta times the sine of x. And again, we simply are plugging in our values. So sine of theta, go up here. Our sine of theta was negative 4/5. So negative 4/5. Cosine of x is negative 5 over 13. Minus cosine theta, so theta cosine is negative 3/5. Negative 3 over 5 times the sine of x. We'll go see what the sine of x was. Okay, 12 over 13. 12 over 13. And now we simplify. Negative 4 times negative 5 is positive 20 over 5 times 13, again, is 65. Minus 3 times 12, negative 36 over 5 times 13, 65. When I have two negatives, that gives me a plus. So 20 plus 56, 20 plus 36 is 56 over 65. And we can't we can't break that down or anything, can't simplify, so it stays just like that. So there you have it, guys. This is our test review for 5.1 through 5.4.